Okay guys, so tonight we're going to talk about our properties: associative, commutative, distributive, and identity property. The distributive property we're going to leave alone, and we're going to come back to that later this year, so we're not going to worry about the distributive property. So if you want to put an X through this right now, we're not doing that. When you open up your foldable, if you want to put an X through this section, that's fine too. So you were given a paper that looks like this. I want you to fold it in half. Fold it in half if you have not already done so. And these are the properties we're going to be going over: associative, commutative, and identity. All right, that's all we're doing. So let's start with the associative property. We're going to go ahead and open up our foldable. Right here, this is algebra, so we're going to write the rule in algebraic form. We're going to give an example with real numbers, and we're going to write the definition here. So let's write the definition of the associative property first. Okay, I want you to just write up here at the top, grouping. The associative property deals with grouping. Okay, you can think of this as like your group of friends is who you associate with. So let's write that down. Your group of friends is who you associate with. Okay, associate just means to talk to and hang out with. Okay, so your group of friends is who you associate with. So the associative property deals with grouping. All right, so that basically says, when adding or multiplying, okay, and it's only when you're adding or multiplying, you can group any of the numbers together and get the, sorry, we're going to go off here, same answer. If you can fit that all in yours, props to you. I write big. Okay, so the associative property means that when you're adding or multiplying, you can group any of the numbers together and you get the same answer. So we're going to remember the associative property deals with grouping. Your group of friends is who you associate with. Okay, associative property deals with grouping. So algebraically, and remember in algebra we use letters. Okay, so I'm going to show you the algebraic form. Some people's brains work well this way. Mine is definitely a brain that works well with numbers and math. So this example portion will really help you number brain people, and if you can think abstractly and think with letters, that's awesome. This will help you too. I'm going to show you both. Okay, algebraically, this is what that means: A plus B plus C. Okay, A plus B plus C equals A plus B plus C. Sorry, I went over to the next box again. Okay, so in algebra we use letters. I don't know if you remember me saying that. All right, now this A, B, and C, they can represent any numbers. That's why we use letters, because they can just represent any number. Okay, so this is saying when you add these two numbers together and then this one, it's the same thing as adding the last two numbers together and then the first one and getting the same answer. Because remember, with order of operations, your PEMDAS, you have to follow the parentheses. Okay, so that's addition. It's the same thing for multiplication. I'll try and write smaller this time. A times B times C is the same thing as saying A times B times C. Okay, so if numbers aren't, or excuse me, if letters aren't your thing right now, that's cool. Let's do some number examples, and that'll help you out. So here's your first example. 3 plus 6 plus 4 equals 3 plus 6 plus 4. 3 plus 6 plus 4 equals 3 plus 6 plus 4. Okay, well, remember, according to PEMDAS, What comes first? Parentheses. So we need to do our parentheses first. What is 3 plus 6? Well, that's 9 plus 4. And then on this side in our parentheses, we have 6 plus 4. So 3 plus and 6 plus 4 is 10. Well, let's see. 9 plus 4 is 13. And 3 plus 10 is 13. Does 13 equal 13? It sure does. Okay, so that's an example with addition. Okay, let's try one with multiplication. 2 times 5 times 4 equals 2 times 5 times 4. You can see I changed the grouping, okay? These two numbers were grouped together, and now these two numbers are grouped together on this side. I changed the grouping. But according to the associative property, it doesn't matter if I change the grouping when dealing with addition or multiplication, because I'll still get the same answer. So let's check. PEMDAS, we need to do parentheses first. So 2 times 5 is 10. We still have times 4. And 5 times 4 is 20. We still have times 2. Well, 10 times 4 is 40. And 2 times 20 is 40. 40 does equal 40, so check, that works. So again, the associative property deals with grouping. So if we look here, 3 and 6 is grouped together, and on the opposite side, 6 and 4 is grouped together. Notice it's the same numbers in the same order, 3, 6, 4, 3, 6, 4. Okay, on this side the 3 and 6 are grouped together, and on this side the 6 and 4 are grouped together. But that didn't matter because when I follow PEMDAS, I still get the same answer. Same thing with multiplication. 2, 5, 4, 2, 5, 4, same order. Okay, on this side the 2 and the 5 are grouped together, and on this side the 5 and the 4 are grouped together. But because it's of the associative property, it does not matter. I'll still get the same answer on both sides. So that's the associative property. Remember, your group of friends is who you associate with. So the associative property deals with grouping, okay? Grouping. It's the numbers that are grouped together. Okay, the next one that we're going to talk about is the commutative property. Commutative property, okay? And with the commutative property, okay, that deals with order. Okay, that deals with order. The commutative property deals with the order. Okay, so what that says is you can add or multiply. And again, this only works for addition and multiplication. You can add or multiply numbers in any order, and you will get the same answer. I'll give you a second to write that down. You can add or multiply numbers in any order, and you will get the same answer. Okay? So the commutative property deals with the order, okay? It deals with the order. You can think of it when here's your house and here's school, and this may be the way you go to school, okay? But on the way back, you may have to take a detour. You have to go up this street and all the way back around. But it doesn't matter, you still got back to your house, right? Okay, so it didn't matter the way you went, the order you went. Normally you go this way. Okay, so you go to school this way and you come back from school to home this way. But there was a detour, so we went a different way in a different order. Okay, but we still got to our house. All right, so let's do algebraically. And there's those letters again. Remember, just letters represent any number. We just don't know what the number is, so we use letters so that we don't have to pinpoint one number. Okay, so algebraically, the commutative property looks like this. A plus B equals B plus A. If you notice, I just switched the order of the numbers on either side, of the letters on either side of the equal sign, but I still get the same thing. They're still equal. Same thing with multiplication. A times B is the same thing as saying B times A. So let's do an example of that with numbers. Okay, let's do addition. 11 plus 6 is the same thing, and I'm going to switch the order. I had 11 plus 6, well now it's going to be 6 plus 11. I switched the order, but let's see if that still works. 11 plus 6 is 17, and 6 plus 11 is 17. Do they still equal each other? Yep. So that works. Let's try it with multiplication. 8 times 7, and now I'm going to switch the order. Make it 7 times 8. Well, 8 times 7 is 56, and 7 times 8 is 56. It doesn't matter the order, I still get the same answer. Okay, so the commutative property deals with order. Your commute to school, you leave home, you go to school. You leave school, you go straight back home. Okay, oh, but there's a detour. I had to go a different order, a different way, but I still got back to my house, right? So it doesn't matter the order, you're still going to get the same thing. Okay, so now we're going to do the identity property. We're skipping distributive. We'll come back to that later on this year. Okay, so the identity property, that says that adding 0 does not change the value. Okay, that's the same thing. Multiplying by 1 does not change the value. Okay, so remember the identity property, or you can think of like yourself, your identity as a person. It doesn't matter what you add to it. You could get a second hole on your ears, okay? Or like your parents, they get tattoos sometimes. It doesn't matter what you do, you will never change who you are as a person inside, okay? So the identity property is no matter what you do, it doesn't change anything, okay? Identity. So let's do an algebraic example. A plus 0 still equals A. Same thing. A times 1 still equals A. Okay? If you notice with all of these, it all deals with addition and multiplication. All addition and multiplication, all our rules. Okay, so let's do an example with numbers. 6 plus 0 still equals 6. So I added 0, but I didn't change 6's identity. It is still 6. Okay? 6 times 1, still 6. I multiplied 6 by 1, but it's still 6. I did not change 6's identity. Okay? So your identity property doesn't change anything. Okay? It does not change. Okay, that's the identity property. The identity property. This one over here, that's the commutative property. Okay, I'm going to turn it on the side and right. The commutative property. Commutative property, and this top one is the associative property. Associative property. Now, yes, I did write those on the side, but if you choose not to write these, that's perfectly fine because it is over here on your front flap. Okay? So the associative property deals with grouping. Your group of friends is who you associate with. So, okay, grouping. Associative property deals with grouping. You can change the numbers that are grouped, but you still get the same answer. The commutative property, okay, means you can switch the order. The commutative property deals with order. Okay, commutative property deals with order. Look, O in order, O in commutative. Okay. All right, the commutative property deals with order. You can switch the order of the numbers, but you still get the same thing. And last but not least, the identity property. Okay, the identity property means that you can add a 0 to it or multiply by 1 and you still get the same answer. You do not change the value. Okay, so those are your properties. Okay, what I want to do now is let's do some examples. I'm going to write an an equation down, and I want you to tell me what's the property that goes with it, associative, commutative, or identity. Okay, so let's do this one. 3 times 4 times 2 equals... What property is this? Good, the associative property. Why is it the associative property? Because associative property deals with grouping. Okay, grouping. I changed the numbers that were grouped together. Remember, your group of friends is who you associate with. Okay, so I changed the grouping. All right, but I still get the same answer. What about this one? 5 times 1. Which property is that? Good, the identity property. Okay, the identity property. I multiplied 5 by 1, but I still got 5. I did not change 5's identity. I still get 5. Okay, now let's try this next one. What's that one? Good, associative property. Thought I was going to do commutative, didn't you? The associative property, okay, remember it deals with grouping. It changed the grouping on each side, okay? Change the grouping. Let's do this one. Which property is that? Good, the commutative property. The commutative property, because I'm dealing with the order, okay, the order of the numbers, O in commutative, O in order. Okay, I changed the order of the numbers, 12 and 5, and now it's 5 plus 12, okay, but I still get the same answer.